Okay, welcome back to the new video series. So today onwards we are going to start our new series about the IGCSE Mathematics for MA1, right? So the course code for MA1, this is IGCSE Mathematics. This is a course code. So I will bring this as a video series starting from the first lesson up to the end of the syllabus, right? So as a continuous series, so we can start it from the scratch. If you are a student who are going to be first for the IGCSE exams or IGCSE Mathematics A exam, so this will be your complete course and this is the lesson 1. So I will be uploading this as a continuous series. Okay, so if I do a brief introduction about the paper structure, so if you are facing the higher tier in mathematics A, there are two tiers, foundation tier and the higher tier. So you have two papers. Paper 1, you have paper 1, that is 2 hour paper, 2 hours, and paper 2 also, uh, you have 2 hours, right? So you get 100 marks for the paper 1 and another 100 marks for the paper 2, right? So combining these two, you get the marks out of 200 and your band will be given according to the marks you obtain. So the band levels or the band marks are changed in each year, but like if you score about around 170 marks or 168, you can achieve a band 9, but it depends with the year, but roughly like that. Okay, and for the higher tier you get bands from band 3 to band 9, and for the foundation tier you get bands from 1 to 5, right? So these are the band structures and basic structure of this course. Okay, the first lesson we can start today. So you can, if you have any doubts regarding the paper structure or whatever the things or whatever the questions you have, you can post that as a comment. So I'll be trying to answer that. All right. So let's start the first lesson. That is special numbers and powers. So this is our first lesson. So when we're talking about the special numbers and powers, we are learning about certain different types of numbers, like prime numbers, integers, and rational numbers, irrational numbers, and what are perfect square numbers, like that. Okay, so some things you might already know these things, but as the start of the lesson or as start of the series, we have to talk about these things because some of you might not have this knowledge, or sometimes you might know what a prime number is, but you might don't know how it came out, like that. So we are going to develop your knowledge from the scratch in this course, right? So these are the special numbers I'm going to discuss. The first one I'm going to discuss about the integers integers. Then second I'm going to discuss about the prime numbers. Then rational numbers, and the fourth one, the irrational numbers. Irrational numbers. Okay, let's make the integers our first topic. So I'm going to take the integers as my first topic. So what do you know about integers from your pre-grades, from the early grades? You might have learned these things, integers, right? So what is an integer? So we can define integer as positive or negative whole number. They're whole numbers, right? No decimals, no fractions, only whole numbers are allowed, and integers. Like if you represent numbers on a number line like this, To the negative side, we have like this. Only these whole numbers are the integers. See, and these things we are calling this as positive integers. Actually, you can't take everything on the number line. You can take the number 3, number 2, and number 1. And here also this number, sorry, negative 2 and negative 1, they are negative integers. Then what can you tell about the 0? I'm asking a question, is 0 is an integer or not? So 0 is also an integer, but it is not included in either positive or negative integers, right? It is an integer, but it is not belongs to positive or negative integers. It is neutral, but somehow it is an integer. You have to keep in that your mind, right? So you might draw this and you can write down the definition. The positive and negative whole numbers are integers. So these are the integers, right? Okay, you can write it down. Okay, so let's move to the next topic. So I mentioned the prime numbers, if you can remember. So what are prime numbers? You know prime numbers, right? What are the examples of prime numbers? You know. So number 2, number 3, number 5, number 7, number 11, 13, 17, like that. You can name it, right? From your pre-grades, you know what prime numbers are, right? Let me write down a few prime numbers. The first prime number is 2, then we have 3, then we have 5, 7, 11, 13, so on. We have the prime numbers. So, but why they are prime? That is my question. So, why they are prime? Okay, let's take the number 2 and we'll write the factors of number 2. So, what is a factor of a number? So, if two numbers multiply to make this number, or the number we are considering, here we are considering the number 2. So 2 can be made by multiplying number 1 and 2, right? So this can be made by multiplying number 1 and 2. So if I take 5, this can also be made by what? Number 1 and 5. If I take 11, again 1 times 11 can be taken. Okay, so I will take another number which is not prime, like, but if I take like number 8, you know, number 8 is not a prime number, but now you know that is an integer, right? So 8 can be made using what? 1 times 8, 2 times 4. Similarly, if I take number 12, how to make it? 1 times 12 we can make 12, then 2 times 6, 4 times 3, or 3 times 4 we can make the 12. So these are the factors, they are the factors of a number. That means there are 4 factors for number 8, 1, 2, 3, 4, 5, 6 factors for number 12. But for the prime numbers, you can see that there are only 2 factors. And there's also one special thing about this, that is, number 1 is always a factor. That is not only common for the prime, but for every number you have, the number 1 is there. So the number 1 is always a factor, and number itself is always a factor. See, number 2 is a factor, number 5 is a factor, number 11 is a factor. Here, 8 is a factor, 12 is a factor. So these prime numbers, they have only 2 factors. They have only 2 factors, and what is other special thing? And those 2 factors are the number 1 and the number itself. And the two factors are number 1 and number itself. So this is the importance of the prime numbers. So these are the prime numbers. If a number has 2 factors, and the number 1 and number itself are the factors, then that is a prime number. So these are not prime because of that. Let me ask a question. So why number 1 is not prime? So number 1 has these factors. Let me take the number 1. How can you make number 1? Number 1 can be made by what? Multiplying 1 by 1. Okay, number one is a factor, but are there two factors? No. Number one is only factor, right? So that's why the number one is a prime. All right, so these are the prime numbers. Oh, I have not written the topic here. So these are the prime numbers. These are the prime numbers. Okay, so that is the second type of special numbers we are talking. You can write this. Okay, next we move on to the third topic I wrote, and they are rational numbers. They are rational numbers. So what are rational numbers? Let me write down the topic. So this one is the rational numbers. Rational numbers. Rational numbers. So how can we tell a number is rational? So this term might be new for you. Integers and prime numbers might be common for you. You might have learned these things before. But what about the rational numbers? What do you know about rationals? Okay, so let's learn it. So here, um, if I write these numbers, right? Let me write number 2, number 3, -5, number 100. Then I will write 0.25. Then I can write like 0.33 recurring. These numbers. I am telling that these numbers are rational. Why? All of these numbers can be written as a fraction. Let me show you how. See, number 2 is always over number 1. So this is the denominator, 2 over 1. Sorry, 1 over 2 is the fraction of this one. Uh, did I cut it wrong? Yes, that is 2 over 1 actually. So this also 3 over 1. Here also -5 over 1. Here also 100 over 1. Here, what over what? This is a decimal, right? So, but we can write this as what? 25 over 100. Do you agree with me? Yes. So, this is a terminating decimals. We'll be learning decimals in the next lesson. But somehow this is a terminating decimal we call. So, that can be written as a fraction. So, you know how to convert decimals in fractions, right? And this goes on and on, 0.333 like that to the infinity. But this also can be written as a fraction, right? So we'll be learning how to convert these decimal numbers to a fraction in the upcoming lesson. So this also can be written as a fraction. So all of these numbers can be written as a fraction. So simply I can tell numbers that can be written as a fraction are rational numbers. All right, they are the rational numbers. Simply I can tell that if two integers, I'm telling the same thing in another way. If two integers a and b are the algebraic terms I use for the two numbers. If two integers, you know what integers are now, a and b can be written in the form a over b, where b is not equal to 0, is called, if two integers a and b can be written in the form of a over b and where b is not equal to 0, are rational numbers. They are rational. Okay. Okay. Are rational. Rational. Yes. All right. If two integers a and b can be written in the form of a over b where b equals are rational. Okay. That means if two integers can be written in the form of a or b, that is as a fraction, that is rational. Why did I mention b is not equal to 0? So if b becomes 0, you know b is the denominator. If you divide from the denominator, that is undefined in maths. You can't divide from the 0, right? That's the reason where the b cannot be 0. Okay, so these are the rational numbers. So now you should think that. So next topic is the irrational numbers. That means irrational numbers cannot be written as the form of fraction. So irrational numbers cannot be written as the fraction. So that is our next topic. So can you think for a while I'm erasing the board, what can be these numbers? Okay. Did you figure that out? Irrational. I will write irrational numbers. And this is for, okay, irrational numbers. Irrational, I should write one R here. Irrational numbers. Alright. Alright, so we have the irrational numbers here. So I told you the numbers that cannot be written as a fraction are irrational numbers, right? So irrational numbers. So irrational numbers are the numbers that cannot be written as fractions. So did you figure out this? So any examples for this one? You might know, right? So in your syllabus, we are talking two types of examples, right? One is the number pi actually. This is number pi, right? So this is a constant. You know what pi is, right? Pi is a constant that is related to the circles. Then when the circumference of any circle divided by the diameter, we get the number pi. No matter the size of the circle, you get the pi. Let me show you, right? So this is for your knowledge, not related to the irrational, but related to the pi. So imagine you have a circle with diameter d1 and circumference c1, a bigger one with the d2 and the c2 circumference. Circumference equals 2 pi r. 2r means 2 times the radius, that is diameter. I can write for this specific circle, c1 equals 2 times r is diameter, that is d1 times pi. The same thing can be applied for this circle. So you can write c2 equals d2 pi. So we'll make the pi the subject. So you can take the d to this side, or you can divide the both sides by d1. So you can write c1 over d1 equals pi, and again c2 over d2 equals pi, right? So this is a constant related to the circles. That means no matter the size of the circle, if you divide the circumference by the diameter, you get the pi value. So this ratio, this constant, is irrational. Why? Because this pi is the value of the pi actually, right? The value of the pi is a non-terminating decimal. What does that mean? Can you remember I wrote the 0.333 thing, the recurring decimals? This is non-terminating. Earlier I also wrote the 0.25 and I told you that that is terminating decimal, that stops at some point. But this is non-terminating. That means if you divide the circumference by the diameter, you get value 3.14. It goes on without recurring. It is not stopping. It can go up to the billionth decimal place, so that more than that, to the infinity actually it can go. I can't remember the rest, but if I write like 762181520016, this is not the exact answer, but it's kind of like this. It's never stopping. So this thing cannot be written as a fraction. How can we? Like imagine you are multiplying this by a billion, you get something or something, but it is not stopping there. It goes to the infinity. That means you cannot write this as a fraction. Because of that, this is irrational, right? Okay, the second example. Okay, I know in this place, so I'll be erasing this part. All right. So I will keep the pi only here. Okay, the second example is that is square roots of non-perfect square numbers. Non-perfect square numbers. I will give you a couple of seconds to think what this means. Okay, I hope you figured this out. The square roots of non-perfect square numbers. So what are perfect square numbers then? If you have a perfect square, one side is 1, this side is also 1. Perfect square, all the sides are equal. The area of this one is 1. 1 times 1, 1. If it is 2, one side is 2, what happens? 2 times 2 is 4. If it is 3, 3 times 3, that is 9. Right? So these are the perfect square numbers. 1, 4, 9, 4 times 4, 16, 25, 36, 49, 64, 81, you name it. These are the square numbers you know. So they are perfect square numbers. That means if I get the square root 4, what is the resulting value? The square root of 4 is 2, the square root of 9 is 3, square root of 1 is 1. They simplify to a integer. That means that can be written as a fraction, so they are not irrational, they are rational. But imagine you have a number like number 7, 7 root. The result of this, you might use the calculator, then check the value of that, this one. This is also a non-terminating decimal. So the value of this equal to a non-terminating decimal. So this also irrational number. So these are the two numbers we talk here. But if you want more examples like number e related to the natural logarithms, you can refer if you want. Also irrational, right? So these are the for special type of numbers we talk under your syllabus, and this is the first lesson. So next we are learning how to convert any recurring decimal into fraction using algebra. That is the next lesson. So I will upload that one also soon. So this is first part. So if you are willing to learn this IGCSE Mathematics A code, please subscribe and add this to your playlist, share with your friends who are doing the subject. Okay, so if you have any doubts, you might write down anything you have in the comments. So I will be try to answer that using a reply or a reply video. All right. Okay, then see you in the next video. All right.